So let's talk about factoring quadratics now. Factoring is just the reverse of the distributive property. And so if we have something like AB times AC, where we notice that there's the same variable in each of these terms, we can factor it out by writing A, the thing that we had in common, and then multiplied by whatever was left over, in this case B plus C. In the first form of factoring, we will be trying to pull out the largest thing in common between all of the terms, the largest factor that is in each of the original two terms. Let's practice. Let's factor the following. 3x and 9. We'll notice we've got just a number on the right, we've got a number and a variable on the left. And if we think really hard about this, we'll notice that each of these things we can divide by 3. And so we could write this as 3 times and then ask ourselves what's left over if we divide it by 3. Well, if we took 3x and divided by 3, we'd have just an x. If we have 9 divided by 3, that's just a 3. And so our final answer is 3 times x plus 3. And we know that this is correct because we can verify using the distributive property that 3x and 3 times 3 is indeed what we started with. Let's try this next one. 27x squared minus x. Well, we don't have any numbers we can pull out this time, but we'll notice that we do have an x in each of these terms. We could divide each of these terms by x, and that would leave us a factor form x times, well, what's left over? When we pull an x out of 27x squared, that leaves just 27x to the 1, or just 27x usually, minus, and if we take x and divide it by x, we aren't left with nothing, we're left with 1. Once again, we can verify that this is right by using the distributive property to see if we get the original expression. Sometimes we have multiple terms. In this case, we want to find the largest multiple that we can pull out of all of the terms at once. So let's take a look. 16x cubed. I notice that I can pull a 4 out of that. I can pull an x or an x squared out of that. 8x squared, we can pull out an 8. We can certainly pull out an x. And then 24x, this is going to limit the number of x's that we can pull out. Remember, we want to pull out the largest factor we can that is in all of the terms here. In this case, we can pull out an 8 out of each of them, since each of these is divisible by 8. And we can also pull out an x. You might think, well, can't I pull out an x squared because of these first two terms? And you can't, because we can't pull an x squared when there's only one x to go around. And so what's left over? Well, if we divide 16x cubed by 8x, we get 2x squared. If we divide 8x squared by 8x, we get just a single x. And lastly, if we divide minus 24x by 8x, we get minus 3. As usual, you should always check if I multiply this through, if I distribute the 8x, do I get the same thing that I started with? All right, this last one looks kind of crazy, a lot going on. A 12, a 24, and a 6. I'm noticing the biggest factor I can pull out there is a 6. We have an x squared, an x, and an x to the 4th. The largest thing we can pull out is an x. And we have a y squared, a y cubed, and a y to the 5th. So that means the largest thing we can pull out is a y squared. What's left over? Well, 12 over 6 is 2. X squared over x is x. And y squared over y squared is just 1, so we don't even need to write that. 24 over 6 is 4. X over x is 1, so again, we don't need to write that. And y cubed over y squared is just a single power of y. Lastly, 6 over 6 is negative 1. X to the 4th over x is just x cubed. And y to the 5th over y squared is y cubed. I'll let you verify that this is correct for yourself.